Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about various definitions and terminology on the module Expert Systems and Application, which is the fourth module on the course Applied Artificial Intelligence. Already I have discussed so many definitions and terminology for the last three modules. First module I discussed for Beyond Classical Search. Next module I discussed the definitions for the knowledge representation. And third module the Beyond Classical Search and like the game playing and the fuzzy logic. For that terminology for that module also many definitions I have already discussed. Now I'll discuss the terminologies related to expert systems and applications. So for this particular module, this is the CO4 for our course, which matches to that module. So after the completion of the course, students can implement an expert system using knowledge acquisition, representation and validation phases to solve domain-specific problems. Now, let me start with the first terminology related to expert systems and application. What do you mean by an expert system? Expert system, it is an AI program that mimics the decision-making ability of a human expert. It uses the knowledge base and inference engine to solve domain-specific problem. Here, two terminologies are used. One is the expert, another one is system. First of all, the expert system means it is a system or it is a AI application or it is a AI program which can mimic like the decision-making ability of a human expert. How a human being can reason and can take its own decision. Similarly, the AI program or AI application can also take the decision by itself without taking any help from the human expert. So if the machine can take the decision like a human expert, then it is called as an expert system. For example, we can use one expert system in our educational institution which can teach to our students. Even the expert system nowadays, it is used in the healthcare system, which helps the doctor to diagnose the diseases based upon the previous report. Even it is also used for the engineers to take the right decision at the right time. So that is why the expert systems, they are the applications, AI applications or AI program, which can mimic the decision-making ability of a human expert. And it uses two important components. One is the knowledge base, another one is the inference engine. Knowledge base, where the knowledge will be stored from the human expert, and inference engine, which can derive the rules or facts or which can derive the conclusion by interacting with the content of the knowledge base for a specific problem, domain specific problem. And one more important thing here I want to tell you that every expert systems are specific, that is domain specific. If we are creating one domain expert system for the educational institution, it may not work for healthcare, and the expert system which is used in the healthcare, that may not help in the banking system. So based on the domain, based on the area, the expert systems will be designed to perform their task, and they can take and they can receive the inputs from the domain experts, and they can reason, means they can understand, they can analyze, as well as they can take the right decision at the right time like a human being or human expert. That is why the terminology is called as expert system. The second terminology is knowledge base. Knowledge base, it is a collection of facts and rules used by an expert system. It serves as the primary source of expertise for problem solving. Now, let me tell you why the expert system is required. Expert systems is in place, it can replace the human being to take the decision or to solve the complex problem. First thing. Now, to take the decision or to solve the complex problem, expert systems should have the knowledge like human being. So that is why knowledge base is required. It is a base or it is a hardware component where the knowledge of different domain experts can be stored in a particular area in that in that hardware component, that is called as the knowledge base. Knowledge can be gathered into that base, that is why it is called as the knowledge base. So that is why it, and how the knowledge will be stored. Knowledge can be stored in the form of facts or the rules. Facts means which is which are constant, like sun rises in the east, that is a fact. Crow is black in color, that is a fact. Sun sets in the west, that is a fact. Rules, how we can find the rules? Like A implies, if I say A implies B and B implies C, definitely A implies C. So this is the rule. So A union B is equal to B union A, that is a rule. So all this knowledge can be represented in the facts or using the rules inside the knowledge base to solve the problem or to take the decision. Next one is the inference engine. Inference engine, it applies the logical reasoning to the knowledge base to derive the conclusion. It evaluates the rules and facts to generate the expert-like decisions. As I discussed, expert systems can mimic the human decision capability like a human being. So the inference engine, it is a engine which can interact with the knowledge base. With whom it interacts, with the knowledge which are stored inside the knowledge base to generate some output. That is why inference engine is required to generate the valuable output for the user. Next one is, what are the phases in the building of expert system? So to build the expert system, different phases are used, like the problem definition, knowledge acquisition, system design, testing and deployment. So these phases ensure the system is reliable and effective. That means before the construction of the expert system, first the problem should be defined. That means for which domain this expert system is required. So that is called as the problem definition. Then based upon the problem definition or based upon the area, the knowledge will be gathered from the domain expert, that is called as knowledge acquisition. Then system architecture will be designed, which is called as system design. After designing of the system architecture, then it will be tested whether it can solve the problem or not for that particular area. If it satisfies, then if everything is okay, then it can be deployed to the real world environment. So that these are the important phases which are used to build the expert systems. The next one is the expert system architecture. The architecture of the expert system includes a few important components like the knowledge base, the inference engine, the user interface, and the explanation module. So these components work together to provide the expertise. As I have already discussed while discussing the expert system, so these four are the important component. The knowledge base, it is a component which acquire all the knowledge from the domain experts, and they are stored in the form of either facts or rules inside the knowledge base. Then after storing the facts and rules inside the knowledge base, this inference engine interact with the knowledge base to derive the conclusion. Then after deriving the conclusion, anyways, how the layman, like we are the layman, how we can interact with the system or the expert system using some user interface, like how our operating system works as an like interface between the computer hardware and the user, and between us. Same thing, user interfaces are required, which allows the user to interact with the expert system so that user can get its output. And one more is explanation module. This is one of the component which is responsible to give all the explanation of the statements. Like if you take the example of the ChatGPT, if you don't understand anything, then again and again we used to ask ChatGPT to make us understand. So that is done by the explanation module, which is responsible to give all possible explanation or the justification about the facts or about the result or about the rules or any knowledge. So these are the four components in the expert system architecture. Next term is the knowledge acquisition, acquiring knowledge from the domain expert. So knowledge acquisition is the process of extracting and encoding the domain specific knowledge from the experts into the system. It ensures accurate and relevant information is captured. To solve a particular problem in a relevant area or in a particular area, the knowledge should be gathered or extracted from from the domain expert. Domain expert means the people, those who are expert in their area. Like a doctor, they are expert in their particular area. Like a faculty, like a lecturer, they may be expert in their particular area. So domain experts, those are called as the domain experts. They can give their expert advice. But knowledge acquisition process says that this process is used in the expert system to extract the knowledge from the domain expert. After extracting the knowledge, it will be encoded into the system, because system cannot understand the normal English language which we extract from the domain people, but it should be encoded in the relevant knowledge representation technique, either in the form of rules or facts or semantic networks, or in other forms, or in the form of logics. So that will be, or in the form of like proposition logic or predicate logic, or in the form of frames. So different techniques are used to encode the knowledge, normal English language knowledge, to the machine, so that machine can understand, it can reason, and it can validate, and it can give the correct output to the user. So that process is called as knowledge acquisition. Next, rule-based system. Rule-based expert system. The expert system, why it is called as rule-based? As I told, the knowledge are stored inside the knowledge base in the form of rule, and every knowledge, to make the machine understand, they are stored in the form of conditional statement, like using if and then. So a rule-based expert system uses if-then rules to represent the knowledge. It applies these rules to input data to produce the logical conclusions. Like if the outside temperature is 30 degree, we can set the AC fan to 16 degree or 17 degree. So like this, we can represent all the knowledge in the form of facts or rules. Next one is the frame-based expert system. The expert system where the knowledge are stored in the representation of frame. Frames already I have discussed in my previous videos. The representation of knowledge using frames means the knowledge can be represented using tabular format, like how the knowledge is stored inside the database in the form of rows and columns. Like all the headers are called as the attributes or the slots, and all the values inside the slot are called as the filter. So this is called as one frame. So frame-based expert system where the knowledge is stored inside, the knowledge is represented using frames. So normally the frame-based expert system uses the structured data representation. Why the structured data? Because inside the frame, similar kind of informations can be stored. If I take the entity employee, all the employee details can be stored in one frame. If we take the example of any student entity, then all the information of the students can be stored inside the student frame. So as it can store all the relevant data to a particular entity, that is why it is called as stereotype database, or it is also called as stereotype frames. So frame-based expert system which uses the structured data representation, that is why it is called as frames. So frames encapsulates related attributes and their values for reasoning. So based upon these values and their attributes, the system can understand and system can generate some output also. Next one is the truth maintenance system. This terminology is very important in the place of expert system. Truth maintenance system, it is a component, we can say, in expert system. It maintains the truthness. That is why the terminology is called as truth maintenance system. Maintains the truthness for the statements, for the facts, or for the rules every time, irrespective of any domain. So truth maintenance system mechanism is used to track and maintain the consistency of the beliefs in an expert system. As the knowledge are stored in the form using rules and facts, which are also called as the beliefs. So for each belief, what is the justification? So for each belief, justification will be stored, and the conditions are also stored. If at any point of time any justification changed, then the belief will be changed, or at any point of time belief changes, definitely the justification will be changed. So that is maintained by the truth maintenance system in expert system. So it updates the conclusions when underlying fact changes. So every time it tries to update with the current knowledge, current belief, and current conditions or current contradictions. The next one is the backward chaining. Backward chaining means from the end to start. So backward chaining, it is a reasoning method. It is used in the expert system which starts with the goal and works backward to determine the required facts and rules. It is a goal-driven reasoning. So backward chaining method, it is used in case of the expert system to derive the conclusion from the goal to the facts. If somebody wants what are the facts we have used to solve this problem, then from the goal, if you move back to generate the facts and rules, that the mechanism is called as backward chaining, which is a goal-driven reasoning. The opposite to the backward chaining, another chaining method which is used, that is called as forward chaining, which is a data-driven reasoning. That means it starts with the known facts and rules and applies to derive the new conclusions. So from the facts and rules, we are deriving the answer. Like if you apply the commutative law or associative law to a particular problem to get the conclusion, to get the output, that is called as forward chaining. From the result, if you want to find what are the rules I applied, that is called as backward chaining. Next one is MySyn. So MySyn, it is the name of one expert system, it is a medical expert system. Especially it was designed around 1970s at the US to diagnose the bacterial infections. It demonstrates the power of AI in healthcare application, as well as it also, based upon the bacterial infection, it suggests the antibiotics for the patient. So MySyn, it is a medical expert system. Similarly, Dendral is also an expert system for chemical analysis, particularly for deducing the molecular structure. It is one of the earliest successful expert systems. So this MySyn, Dendral, these are the name of the expert systems which are used in healthcare, in chemical analysis. Next, what is knowledge engineering? Knowledge engineering, it is a process of designing, building, and maintaining the expert system. How to design the expert system, how to build, how to maintain. Designing means architecture of the complete expert system, including all the knowledge base, how to design the knowledge base, how to design the inference engine, how to design the user interface, from whom we will take the help, like knowledge engineers, they involved for designing this architecture of the expert system and for collaborating all the components together, which is called as the building. And after building the expert system, the deployment will happen, and continuous 24/7 365 days it will be maintained by a certain set of people or the maintenance people. So together, the designing, building, and maintaining of the expert system, this process is called as knowledge engineering. It involves the collaboration between the domain experts and engineer. It is not a single man task for designing, building, and maintaining the expert system. Domain experts are responsible to provide their domain ideas. Domain engineers are also responsible for this, for all the three: designing, building, and as well as maintaining. And we are the simple layman. We do not know anything. We don't have any knowledge about artificial intelligence. We want the answer only. So we can interact with the expert system through the user interface. So, but how the expert system works, how it designed, how it is built, that is done by these knowledge engineers or the AI engineers. Even here, domain experts are not the knowledge engineers or the AI engineers. They are the experts in their particular domain. Only they are responsible to provide their expert advice to the system, so that system can understand and system can reason and system can provide the correct output to the outside world or to the user. The next one is the rule-based reasoning. What is the meaning of rule-based reasoning? It is a reasoning method based on rules. So it uses the predefined rules to draw the conclusions. It is a straightforward approach to simulate human-like decision-making in expert system. So if the reasoning is done based upon the predefined rules, then it is called as rule-based system. The next terminology is case-based system. It solves problems by comparing them to previously solved cases stored in the database. It relies on the similarity between the cases for solutions. That means the reasoning method happens in the expert system by following the previous solved cases. Then it is called as case-based reasoning. Then domain experts. So domain experts are the people or the expertise in their particular area. They are the human specialist, we can say, who provides the knowledge and expertise to build the expert system. Their input is very crucial for the system accuracy. That is why for building for the correct output or the accurate output or the efficient production or efficient output of the expert system depends upon the knowledge of the expert or domain expert. If domain expert gives the wrong ideas, definitely system cannot manipulate, system will give the wrong answer only. So domain experts are very important role in the field of the expert system. The knowledge representation. Definitely the knowledge representation is required to represent the knowledge inside the knowledge base. Then only the output can be generated by the inference engine. So knowledge representation, different types of knowledge representation techniques are used, like it can be represented using if then or rules or facts, or using semantic networks, or using frames, or using different types of proposition logic or predicate logic, or using some inference mechanism. So it involves encoding the information in a form that an expert system can use. Methods using like rules, frames, and semantic networks. That is the terminology is called as the knowledge representation. Then what is fact base? The knowledge base, if it consists of all facts, repository of the factual data, then the base is called as the fact base. It is used by the expert system. It works alongside the rule base to derive the logical conclusions. Then what are the applications of expert system where it is used? Expert systems, basically they are used in the field of medicine, engineering, finance, and customer support. It's not like only these four fields. Irrespective of any domain, expert systems can be used. They provide the domain specific expertise to solve the complex problem. So I hope you might have understood all the terminologies what I have discussed in this video related to the expert systems and its applications. And for the preparation of this video, I referred the Soros book for artificial intelligence. For your reference, I kept the picture of the artificial intelligence book by Soros, which is available in the Amazon website. You can also refer it. So thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.